Hi Algebra 2, this is your first night that you guys are going to be taking notes on your own before you come into class tomorrow. So I want to give you guys a little background information about why the way that I structure the notes looks like Cornell style. If you guys aren't familiar with Cornell, we take all the notes on the left-hand side of the page. Your topics, your questions are on the left. All your notes that I'm going to be writing with you, like examples and definitions, all of that's going to go on the right. And it basically takes students who are passive listeners to turn into active listeners. If you are actually thinking about the questions that I'm asking, thinking about how we're summarizing the information, and then also thinking about what the notes are that we're taking. So again, you guys aren't teaching yourselves with this flipped classroom idea, but we are trying to get a sense of what I'm about to talk about the next time I see you before you guys come to class. So it's like you're previewing the material before you walk in, which is really what studying is all about. And that's what you guys will be doing throughout the rest of high school and when you guys get to college. So there are some things that you definitely want to make sure you're always prepared, just like a job. You want to make sure you're prepared before you come into work the next day. So that's what we're doing with our class as well. If you guys take a look at the active listeners part, a couple things that really stand out is we do want to be students who want to find something in the lecture, something that interests them. I know not everything in math is interesting, but we want to find at least something. We assume that the information in a lecture will be useful, and if not now, maybe later, so you're seeing worth in what you're doing. You may not notice the weakness in the speaker's style, but you pay attention to what the speaker says. So a lot of times when we're not listening for information, you're kind of thinking about what the teacher's saying more than what the information actually is. So this video already takes that part out of it because you guys can't see me. And then you guys can read a couple of the others. But a few that I want to highlight is I want you guys to be listening, see whether you disagree or agree with the speaker. Try to understand difficult information or technical information. Ask questions. Since you guys can't ask questions, I would try to support the fact that you guys can write down questions, because the next time that I see you, we'll have a chance to really talk about the questions that you have, all right? And then taking well-organized notes. That is what I'm trying to get you guys to do. So with the video, you guys have the advantage that you can pause the video, you can rewind it, you can watch it multiple times, or you can go through it once, depending what your style is, but you have that option if you need it. So without further delay, we are going to go into our first night of notes, which is our Quadratics unit, Chapter 3. Day 1, imaginary numbers. Go ahead and label the top of your page with Day 1, imaginary numbers. Again, you can always pause if you need more time to look at it. And what you guys will notice is we are going to start with two questions. And the first question is, what happens when you take the square root of a negative number? A lot of times, we often think about, well, how do we wind up taking the square root of a number? We've been talking about perfect squares, and I know the perfect square, or the square root of 9, because 9 is a perfect square, I know it's 3. But the problem is I need to find two of the same numbers to multiply to make a negative 9. If I multiply 3 times 3, I get a positive 9. If I multiply negative 3 times negative 3, I get a positive 9. So I need to have one positive, one negative. But the definition of a perfect square is that the two numbers have to be the same. So it doesn't really work well. Same thing with 25. I need 5 times 5 to make a positive 25. If they're both negative, they still make a positive 25, so I'm stuck. So mathematicians a long time ago figured, well, I need to have something to represent this situation because it's going to come up a lot. So what they figured out was they said, well, the square root of negative 9 is really the same thing as the square root of negative 1 times the square root of 9. Since I know the square root of 9 is 3, what could I do with the square root of negative 1 thing? What could I do with it? Because it's not something that I'm familiar with, right? It's something new. So what mathematicians did was they gave it a name, and they said that the square root of negative 1 is going to be represented as I. And I'm sure you guys can guess what I stands for, since they are called imaginary numbers. I is your imaginary number, and it stands for the square root of negative 1. So when you guys look at some of these examples, for example, the first one, square root of negative 9 can be represented as negative 1 times 9. They're both still under the square root. When I take the square root, Well, the square root of negative 1 is I. The square root of 9 is 3. So I get I times 3. And the most proper way to write that is always to have the number in front. So I basically get 3I. Similarly with number 2, negative 25 can be written as negative 1 times 25. So I can go ahead and say, well, the square root of 25 is 5. And because it's negative, I'm going to put the I next to it. Same deal with negative 4x squared. I know that 4x squared comes from 2x times 2x. And then because that negative is on the inside of the square root, I have to make it an imaginary number. Negative a squared under the square root. Again, because the negative is inside the square root, I know that a squared comes from a times a. And then I need the I next to it because it's negative under the square root. Anytime that the negative is under the square root, then I have to make it an imaginary number. Let's look at number 6. Number 6, I have a negative 4, but the negative 4, notice that it is outside the square root. So it is not underneath the square root, so that negative 4 is not imaginary, it's just a negative 4. But underneath the square root, right here, I have negative 9z squared. So that negative 9z squared is 3, and z, 3z makes 9z squared. And because it's negative underneath the square root, I have to give it an I. So really what I'm saying is I have negative 4 multiplied by 3zi. And we multiply this just like you would any other expression. The negative 4 and the 3 make negative 12, and then I continue to have the z and the I all multiplied. Let's try the last one. Negative 100 is underneath the square root, so that gives me a 10. The a squared square root is a. Square root of b squared is b. And because I have that negative underneath the square root, I have to put the I next to it as well. So anytime that we see an I, we're not going to use I as a variable anymore because I stands for an imaginary number. Again, pause the screen here if you want to look back at these problems or try them yourselves. All right, so now we're going to look a little bit more at the powers of I. So if I take, sounds very magical, the powers of I. If I'm going to take I, the imaginary number, which stands for the square root of negative 1, I'm going to now raise it to a couple different powers and just see what happens. So I to the first power is I, and we know that I is equal to the square root of negative 1, and I'll put that on the side here. So now if I take I squared, well, I squared is I times I, so that would mean square root of negative 1 times square root of negative 1. When you multiply a square root of one radicand times the square root of the same radicand, so in other words, the number that's inside the radical is the same, what happens is the radical cancels out, and now I just have the negative 1, right? Because, and we'll talk later about the exponent rules and why that happens. So basically what happened so far is if I have I to the first power, I have I as my answer. If I have I to the second power, I have negative 1 as my answer. I to the third power would be I squared multiplied by I. So that would be negative 1 times I. So I get negative I. Then I to the fourth power comes from I squared times I squared. Well, let's look back. I squared is negative 1. So negative 1 times negative 1, I'll put parentheses around that, gives us positive 1. So we're going to continue. I to the fifth. I to the fifth. I can make 5 out of I to the fourth times I. So I'm going to take 1 times I. So now I get I again. And I to the sixth, I can make 6 out of 2 3's. So I can do I cubed times I cubed, which is negative I times negative I. Negative I times negative I makes positive I squared, and I squared is negative 1. So I did all that work and got back to negative 1. I to the seventh, I can make 7 out of 4 and 3. I to the fourth is 1. I to the third is negative I. I'll put that in parentheses. So I get negative I when I multiply those. Are you guys seeing the pattern? I to the 8th, I can make 8 out of 4 and 4. So I to the 4th times I to the 4th. And that makes 1 times 1, which makes 1. So let's take a look back up from the top. I to the first power is I. I to the second power is negative 1. I to the third power is negative I. I to the fourth power is 1. Now I start to repeat. I to the fifth power is I. I to the sixth power is negative 1. I to the seventh is negative I. And I to the eighth is positive 1. What you guys notice is these 4 repeat. And if you guys want to test it out, they will repeat forever and ever and ever until you get up to a super high number. So you guys can actually reduce the amount of work that you need to do if you remember this pattern. So as soon as I get a test or as soon as I get a practice, I did this in high school as well, I wrote down my pattern. I put on the side, here's my little side note, okay, my little brain bubble. On the side of my paper, I wrote down I, negative 1, negative I, positive 1, because that repeats forever and ever. So now let's look at some of these examples and see how that helps us. This first one, oh boy, is that small? Let's try to make that a little bit bigger so we can see it. There we go. Okay, we'll do those together. So the first one says I to the 9th power. And I'll rewrite that. I to the 9th. Well, if you guys come over to your side note, notice that I to the first is I to the second is negative 1, I to the third is negative I to the fourth is 1. And I'm going to continue that until I go 9 times. So I'm going to say 1 is I, 2 is negative 1, 3 is negative I, 4 is 1. Start over. 5 is I, 6 is negative 1, 7 is negative I, 8 is positive 1. Start over. 9 goes to I. This next one is I to the 12th power. Well, 12 is divisible by 4. So that means if I count down this pattern, I is 1, negative 1 is 2, negative I is 3, and then 1 is 4. So if I do this, start with I, I'm going to use blue to show you guys. I to the first, I to the second, I to the third, I to the fourth. Go back up to the top. I to the 6th, 7th, 8th, here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I end at that same spot, which is 1. Any number that's divisible by 4 will always bring us back to 1. So if I think about that in the next example, and I say, okay, I to the 15th is what I'm looking for. I to the 16th would be divisible by 4. So that means I to the 16th would be at 1. So I know I to the 15th is 1 less than that, which makes negative I. Here we have I to the 46th power. And I to the 46th, okay, 44 is divisible by 4, right? So 44 would bring me to 1, and then I have to go 2 more. So 45 would be back at I, and 46 would be at negative 1. And then we have I to the 107th. I to the 107th. So 100 is divisible by 4, which means 104 is also divisible by 4. So 104 would put me back at 1, and then 105 would be back at the top, I. 106 would be negative 1, 107 would be negative I. And that pattern, again, the more that we know that pattern, it'll help us find anything that we need to. Again, guys, pause the video as you need to. This last practice set is really what we're going to do a lot of in class when I see you guys next. How do we simplify expressions that have imaginary numbers in them? So you'll notice that all of these have i's in them. We are going to treat i's just like x's. So when you guys are simplifying, we are going to take 5 plus I, distribute the negative, and we'll get negative 3i and minus 2. Look for your common terms. So I can put my 5 minus 2 together and get 3, and I can have I minus 3i and make negative 2i. And that would be my final answer. We just spent an entire unit on practicing simplifying expressions, so now we're going to do the same thing with I. I'm going to go ahead and pause here and put the answers up in a minute. You guys practice and then check. Check your answers and see you tomorrow.